Here I am at the University of Missouri, and we're on the campus right now. This campus is host to the longest running continuous cropped agricultural land in America. 150 years. The plots are just behind this building. Well, here I am at the University of Missouri, and I'm on the Sanborn Fields. This was established in 1888. It's the longest running agricultural farmland in North America, or so they say. Behind me is the Life Sciences building, so we spend a lot of time in there, and the Life Sciences building is where they do a lot of the current microbiological work, including microscopy and DNA analysis. So here you have the continuum of the oldest conventional agriculture in North America, here at the University of Missouri, all the way through to the brand new technology of the Life Sciences building behind me. I'm now in the Sears growth and plant facility here at the University of Missouri. This facility is designed to do everything from taking transgenic material and integrating it into new plant species and offering services to the public and private sector. Here we are looking right now at generation of a Arabidopsis, which is a plant that's particularly easy to work with in terms of genetic manipulation. Arabidopsis is a common plant that they're using, and very closely related, in fact, is Camelina that also can be used, and we've done some work with that in Canada. Here we have a soybean growth chamber, and this soybean growth chamber is being used to test out different attributes here. And this is all DNA manipulation here, and every one of these growth chambers, of course, mirrors a specific climate. And it's quite the facility. They've got large labs downstairs with growth chambers, as well as small areas, small lab space where they can do manipulation of genetic material onto agar plates and propagation. So I'm here today at the Danforth Center. This is in St. Louis, Missouri. And as you can see, the Danforth Center was established in 1998. Really, the building was put together and built, opened up, I guess, in 2001. The backside over there, you can see some of the greenhouses, and over behind it is the Bridge Center. The Danforth Center is a center for a nonprofit center where companies can bring their ideas and collaborate with over 19, soon to be 21 scientists that work in various disciplines. They are working on food density projects, they're working on disease control projects around the world. It's all about enhancing the human condition through plant genetic engineering and plant science. So we're in the Danforth Center, and we're in the algae lab, and they have an extensive study on algae for biofuels here at the Danforth Center. And they have two photoreactors here, and these are photoreactors, and apparently they allow us to do a lot of work on the efficiency and differentials between algae production. So this is a brand new area of study, and algae has the potential to provide extensive production of biofuels and alleviate that stress on corn. So one of the future technologies coming out of the Danforth Center is a look at algae, all the different forms, and apparently not much is understood yet about algae at the microbial or microbiological level. So all they're doing here is they're plating all the different algae to try to find out what the differentials are and seeking eventually how to use that for biofuel production. Wow, this is pretty cool. So I'm in a greenhouse right now at the Danforth Center, and the greenhouse that we're into is a greenhouse studying the production of Camelina. This is a crop that we grew in Alberta several years ago. It has the potential for oil production. As you can see, there's some Camelina down here at the stage that's ready to harvest, and we have some Camelina above that is just starting to emerge. The crop can be used for oil, it can be used for starch production, it can be used as in medicine by helping vaccines enter the body, because it's got very, very small molecular size, and it has got some drug tolerant capabilities as well. So here at the Danforth Center, they're looking to see if they can't turn Camelina into a commercial crop. One of the problems with Camelina is weed control. It closely resembles a lot of the weed species that we have in Canada in particular, and so the taking out of the weeds of a camelina crop is an issue. Nonetheless, it shows promise. So here is a look at camelina, and it's good to see it here in the laboratory after we saw it in field production outside of Lacombe, Alberta several years ago. In the Danforth Center, we're at the greenhouse facility. Here is the plant Cassava. The temperature inside here is like sub-Saharan Africa, and Cassava is a staple crop for millions of people around the world. There's a number of things they're working on here, which is the nutritional density of Cassava. They're trying to get more zinc and iron and vitamin A inside the Cassava crop. The other one is, of course, the breeding of the Cassava crop to fight the virus that attacks the Cassava, rendering it virtually useless in Africa. So for millions of people around the world, this is a staple food crop, and the Danforth Center has been using their technology and some of the bioengineering techniques to try to increase the usefulness of this crop and increase the human condition by helping this crop to survive and be more nutritious. This is a growth chamber here at the Danforth Center. They start the plants off at the microbial and cellular level and generate them out. So they'll do genetic modification at the cellular level, and they'll take the plants and grow them out for propagation and testing. The facility here does contract work and is available, and apparently they're very, very busy, so they're expanding their facility right now. I'm in the microscopy area of the Danforth Center, and the reason I got on these 3D glasses is on the walls behind me are a number of photos that are photographed in 3D, and they're quite interesting as you look at the photos. That one is of endoplasmic reticulum. With the 3D glasses on, you just get a visualization as to the depth and how these various plant parts function. Here we have one, the plant hairs coming out at you. That center part just rises through the 3D glasses, and this one over here of the endoplasmic reticulum is really quite amazing. So these guys have the ability here to do some amazing work at the well, pictures, I guess, at the cellular level, and that's what they're using here in this laboratory.
We call it the cytology core, molecular cytology core. And this is where people come to take those pictures that we saw upstairs. There is pretty much nothing you can do with a light microscope that you can't do here. You'll see the bright colors all around us here, all the different colors. Those are pretty much all playing the trick that I described upstairs, where a gene has been tagged with a fluorescent protein that lights up in a certain light wavelength, allowing people to see where particular genes are going on and off in the organism. Let's see, is there an easy one? Yeah, well, here's a fly head, fly brain, and everywhere these people were interested, it doesn't matter exactly what it is, they were interested in this particular enzyme, tryptophan hydroxylase, where the gene is going on, and every place you see bright green, that's where that gene is being turned on. So this kind of thing allows you to do, if you're interested in that. Oh yeah, see, these seeds have been lit up by being transformed with the green fluorescent protein in their outer coat. I think that's mainly to be pretty, I'm not sure. But.
So quite a fantastic facility. Again, this is available for companies to work with, and behind the Danforth Center is the Bridge Center that takes the companies over there will come and utilize the services of the Danforth Center. And we just visited with the CEO of Divergence, who is developing nematode products to help farmers fight nematodes, and they commercialized some of the work that they had done into patents and recently sold out to Monsanto, who are going to take that product to the marketplace in 2015. So the Danforth Center, pretty amazing facility. I think we'll have to follow this one going forward.